In this long tutorial on repository pattern, we will successfully implement it on ASP.NET Core Razor Pages app. Create a new ASP.NET Core application in Visual Studio. Select the template called ASP.NET Core Web App, which will create the app based on Razor Pages. Give your app the name Movie CRUD. Waiting a few seconds, the Razor Pages app will be created, and then you can add new features to it. Will start with installing Entity Framework Core to the app, because it will be used as a database access layer to create CRUD features. So, we will have to install following two packages from NuGet: Microsoft.EntityFrameworkCore.SQL Server, and Microsoft.EntityFrameworkCore.Design. Next, we will need to create the entity which will be a movie.cs class. You have to create this class inside the models folder. So first create models folder, on the root of the app, and then inside it create the movie class. We will be performing the CRUD operations for movie records, so the movie entity is created for this purpose. It has three fields: ID, name and actors. Name and actors are made required by putting required attribute over them. So movie records cannot have empty name and actors values. Entity Framework Core will make the name and actors columns on the database when migration is performed. Both of them will be made not null types. Database context is a primary class, which will interact with the database. We will need to create it inside the models folder. So, create movieContext.cs class to the models folder. The movie context inherits the dbcontext class of Microsoft.EntityFramework Core namespace. It has the object dbcontext options defined on its constructor as a dependency. ASP.NET Core dependency injection will provide this object to it. I have also defined all the entities, where Entity Framework Core work as dbSet on this class. Since we only have the movie entity, so it is defined as dbSet. Next, we need to register the movie context on the startup.cs. So, inside the configure services method, add the following line which will register our database context. We are now ready to perform Entity Framework core migrations, but before that, we need to define the database connection string inside the appsettings.json file. I am using MS SQL Local DB, and the database name is MovieDB. So, let us perform the migrations. After the migration commands finish executing, you will find a migrations folder created on the app. This folder contains newly created files that were used to create the database. Next, go to View SQL Server Object Explorer, where you will find the MovieDB database. This database is created when we ran the migrations. This database will contain only one table called Movie, which corresponds to the movie entity we created in our ASP.NET Core Razor Pages app. Repository pattern needs, interface and class which will implement inherit the interface. The repository is a generic type, where T is constrained as a class. This means T must be a reference type like a class, interface, delegate, or array type. The interface will contain all the methods that will be dealing with database operations like CRUD. Commonly, you will have methods for creating, reading, updating or deleting the records on the database. Sometimes, we will have a few more methods for dealing with filtering of records. I have defined a single asynchronous method called createAsync in the interface. Next, we create a new class called repository.cs inside the same entity folder. This class will implement the interface we defined earlier. The constructor of the class receives the movie context object, which is the database context of fcore, in its parameter. The ASP.NET Core dependency injection engine will provide this object to the class. The createAsync method is doing the insertion of the record to the database. It gets the entity of type D and its parameter, and inserts this entity to the database using Entity Framework Core. There is Pages folder on the app's root folder. You need to create a new Razor page inside this Pages folder, and call it create.cshtml. So, right-click the Pages folder and select Add New Item. Select Razor Page Empty Template, and name it as create.cshtml. The Razor page will be created. Add the following code to it. There is a model defined for the create.cshtml Razor page, and it is named createModel. We define two input type text elements on the form, which are binding with the name and actors properties of the movie type object. The class by the same model is defined. The class inherits the page model abstract class. The constructor of the createModel class has a dependency for a repository. The dependency injection feature solves this by providing the repository object to the constructor. Recall we earlier registered this dependency in the startup class. Next, see movie type property defined, and it has bind property attribute. This means, this property will get the value from the HTML elements defined on the form, when the form is submitted. This type of binding is done automatically by ASP.NET Core through Model Binding feature. The Razor pages have handler methods that are automatically executed as a result of HTTP request. There are two handler methods, onGet and onPostAsync. The onGet will be called when HTTP type GET request is made to the Create Razor page, while the onPostAsync, which is async version of onPost, is called when HTTP type POST request is made to the Create Razor page. Note that the model state is valid only when there are no validation errors. So, this means the movie record is created only when all the fields are filled. We need to register the interface to its implementation in the startup.cs. Register it in the configure services method. Now, run Visual Studio, and open this page on the browser by its name. The localhost port will be different for you. Without filling any of the text boxes, click the Create button to submit the form. You will see validation error messages on red color. Now, fill the values of name and actors, and then submit the form once again. This time, you won't see any errors on the page, and the record will be created on the database. Now, on the SQL Server Object Explorer, right-click on the movie table, and select View Data. You will see the record is inserted on the database. Congratulations, we successfully inserted the record with generic repository pattern. Next, we will see the reading part. Now, we will build the read movie functionality. So, we need to add a new method to our repository, which will perform the reading task. So, go to the repository interface and add readAllAsync method. The readAllAsync method returns a list of t-types asynchronously. Next, we will have to implement this method on the repository.cs class. Create a new Razor page inside the Pages folder, and name as red.cshtml. And add the following code to it. We have created a link to the Create Razor page, with the help of Asp Page Tag Helper. Below the anchor tag we have an HTML table, which contains 3 columns for the 3 fields of the movie entity. The table will be showing all the movie, which are currently stored in the database. The HTML table has a for each loop, which structures each record per table row. Run Visual Studio, and navigate to Read page, where you will be shown the movie record created earlier. This shown the read operation is working perfectly. We have created the reading of the records, but there is no paging. I created a few more movies, which will show together on the read.cs HTML Razor page. This will also cause problem like slowing the page, when the number of records increases. To solve this problem, we will create Pagination feature. So, create a new folder called Paging on the root of the app. To this folder add 3 classes which are paginginfo.cs, keep track total records, current page, items per page and total pages. movielist.cs, contains the list of records of the current page and paging info. PageLink taghelper.cs, it is a tag helper, which will build the paging links inside a division. The PageLink tag helper does the main work of creating paging links. The tag helpers must inherit tag helper class, and should override the process function. The process function is the place where we write our tag helper code. Here in our case, we will be creating anchor tags for the paging links, and show them inside a division. The tag helper class is applied with HTML target element attribute, which specifies that it will apply to any div, which has page model attribute. The tag helper class has defined a number of properties, which will receive the value from the Razor page. These properties are page model, page name, page class is enabled, page class, and page class selected. The tag helper gets the object of IRL helper factory from the dependency injection feature, and uses it to create the paging anchor tags. There is another property of type viewContext, which is binded with the viewContext data, which includes routing data, view bag, temp data, model state, current HTTP request, etc. The use of HTML attribute not bound basically says that this attribute isn't one that you intend to set via a tag helper attribute in the Razor page. We have pageOtherValues property, defined as a dictionary type. This property gets the values in dictionary type from the attributes that starts with pageOther. Examples of such attributes can be pageOtherSum, pageOtherOther, pageOtherData, pageOtherName. The values of these attributes will be added to the query string of URL. The function addDictionaryToQueryString defined on the class does this work. Although I have not used it, but it can be useful if you want to add more features to your tag helper class. The next thing we have to do is to make this tag helper available to the Razor pages, which we can do by adding this code line inside the _view imports.cs HTML file. Next, we need to integrate this tag helper on the read Razor page. So first we need to add new method to our repository. Add method called readAllFilterAsync to the repository. This method returns a tuple of type list indent. This obviously means it will return a list of records of the current page and total number of records in the database. Other than that, it takes two parameter skip and take. They help us to build the logic to fetch only the records of the current page. Next, add the implementation of this method on the repository.cs class. We are fetching only the records of the current page by the use of length skip and take methods. Go to read.cs HTML and do the changes. We added a div containing the page model attribute, and so the tag helper will convert this div to pagination links. The movie list property, added to the class. This property is then used in the for each loop, which is creating the table rows from the records. The model.movie_list.movie will now contain the list of movies. Now, moving to the onGet handler, which now gets the page number value in its parameter. Recall, we have added it to the page directive some time back. I have set the page size as 3, which you can change according to your wish. The current page and the items per page are added to the paging info class object. Also, the value of the starting record for the page is calculated and added to the skip variable. Next, we call the readAllFilterAsync method, with the value of skip, and the number of records. The method returns tuple, whose value is extracted, and provided to the total items of paging info, and movie of movie list. We provide paging info property, of the movie list object, the value of paging info. Go to read.cshtml, and do the changes. ID route is added to the page directive. This is done because the page number will come in the URL. One more change is needed now, on the create.cshtml razor page. This change is on the onPostAsync handler. We are now redirecting to the first page of the read razor page, in case the new record is successfully created. Now, run Visual Studio, create a few movie records, you will see the pagination links working excellently. For large number of pages, the pagination will add two dots before and after the last and first page's links. Next, we will create the update operation. Add a new method called update async to the repository interface. Also implement this method on the repository.cs class. The update async method is updating the entity in the database from the last two lines. After this, we need to create a new Razor page called update.cshtml in the Pages folder. Next, add the following code to it. The code of the update Razor page is very similar to the create Razor page, just a few changes. In the onGet handler, the repository is called to fetch the record, whose it the handler receives in its parameter. The record's ID will be sent to the update razor pages as a query string parameter. We calling the read async method of the repository, and passing the value of the record ID to be fetched to it. This means, we will have to add this method to our generic repository. So, add this method to the repository interface. Also, implemented on the repository.cs class. The method uses the find async of entity framework core, and passes the ID of the entity, which needs to be read from the database. Another thing we need to do is to link the update page from the read page. The table on the read.cs HTML, which shows the movie records, is an ideal area for this. We will add another column for the table. An anchor tag will be added to this column. This anchor tag will be linking to the update page. The anchor tag's href value will be created by ASP-page and ASP-route tag helpers. The ASP-page is provided with the name of the page, which is update, while ASP-route is provided with the name of the route, which is ID. The ID value is added to the tag helper from the for each loop mechanism. Run the app on Visual Studio, and go to the read pages URL. Here, you will see blue update link against each record on the table. Click the update link. We will be taken to the update razor page. Here you can update the first record. Notice, the ID of the record, which is 1, is sent in the URL as a query string. This completes the update record CRUD operations. We are now left with only the delete operation. Start by adding method called delete async to the interface. This method accepts ID of the entity as a parameter. Also implement this method on the repository.cs class. In this method, we used find async method of the repository to find the entity by its ID. and then, deleted the entity with by entity framework core remove method. Next, moving to the razor page. We will not need to create a new razor page for the delete operation, in fact we will use the read page for this. To create the delete CRUD operation, we will add another column to the table on the read razor page. This column will contain a delete button which on clicking will delete the record. Notice, we created a form, and a button inside it. This button will post the form when clicked. We will have to add on post delete async handler to the read class file. This handler be called on the click of the delete button. The onPost delete async handler is an asynchronous handler as it is async on its end. The term onPost at the beginning of its name specify that it is post type handler. This method calls the delete async method of the repository and sends the ID of the entity to its parameter. Run the app on Visual Studio. On the read page you will see delete button on each row of the table. Click on any button to delete the entity from the database. Let us create a feature to search an entity by its name using link expression. Add a new method called readAllAsync to the repository interface. This method will have expression type parameter, which can be used to send filter expression. Now, we create a new Razor page inside the Pages folder. Name this page as search.cshtml, and add the following code to it. The page has an input tag, to enter the name for the int issue to be searched. The value of the input tag is bind to the movie property. Inside the onPost async, we create the filter expression to match the name as that entered on the input tag. Next, we pass the expression to the readAllAsync method of the repository. Finally run the app, and go to the search page, and perform the search.